illustrate in full detail the mechanism for the chlorination of methane. So the first thing you want to come up with is initiation. That's where you have a chlorine molecule, Cl2. So full detail means Lewis structures and formal charges wherever we need them. So HV, what does HV stand for? V is frequency, H is Planck's constant. So that means a photon with some energy, and now I have a half arrow. There's 2 electrons in this sigma bond, and that's going to give me 2 chlorine radicals. That's initiation. The next step we can call propagation, and we actually have what I call the first one, methane up here, and a chlorine radical. So you want to use half arrows to show this electron, an electron from one of those electrons there, and so now I get my alky radical plus some HCl gas. And this is the rate limiting step. You can call it the rate determining step. And that's the formation of the alky radical. And we can have a second propagation step. We got the alky radical countering chlorine molecule. Half arrows mean the movement of electron. A double arrow would be a pair of electrons, but we still use the same formalism where the arrow starts at electrons and moves to atoms. So now we have our chlorinated product, and we've produced another radical, so that radical can go on and keep the process going. Then we have termination, things that shut down the reaction. 2 methyl radicals can counter each other, give us ethane. And of course we can get a termination reaction that's going to lead to our desired product. So it looks like a 5-point question. And we got 1, 2, 3, 4, 5, 6, really 7 points. Knowing the mechanism for each step, knowing that this is the rate limiting step, all really good things. Any questions? Steps are in this reaction. Adjacent states. Which is the rate limiting step? Well, if there's 3 steps, your options are the first one, the second one, or the last one, right?
Second one.
Very good. So why is that?
Because it's the biggest.
Right.
Is that right? I'm sorry.
It has the highest energy of activation. How many intermediates are there? 2. Very good, yes. There are 2. Evidently there's an intermediate there and another intermediate there. Is the reaction endothermic or exothermic? It is exothermic. You think this is going to have a octane or heptane root to it? So here's what we want to do. We're going to call this cyclobutyl group our first substituent. And it's connected to carbon number 1. So students always like to make this carbon 1 and it messes everything up. It makes this carbon 2, this carbon 3, this carbon 4, this carbon 5, this carbon 6, and that carbon 7. So we're going to say we have 1 cyclobutyl, and then chloral before methyl, 3 dichloral, 4 dimethylheptane. How would we name this? Yeah, they're both on the same side of the ring.
It's 3 and 2.
Draw the structure of the least stable alky radical. What's the least stable alky radical? Well, what's the least stable carbocation for that matter? Methyl. So what kind of radical is this? Yeah, it's ethyl, but is it secondary, tertiary, or something else? It's primary. So what's left is a secondary. Draw the structure of the most stable alky radical. What do you think that's going to look like? And that's our trend for right now.